I'm going to show you how to fix this Samsung Plasma with model number PN51F8500. The most common symptoms we see is that it's completely dead, it has no power at all, or it does have power but it's intermittent, and when it does turn on it will eventually shut itself off, or it has sparkles on screen, so sometimes you have red or black sparkles. The reason that those symptoms occur most commonly is the power supply board. So we're going to take a closer look at it using our multimeter and see if we can identify any faults. Our TV is disconnected from power. I have my multimeter in beep mode, so when I detect a short, I get a beep. First thing we're going to do is check our fuse. A shorted fuse is a good fuse. I get a beep, that means I have a short on my fuse. That's good. We're going to check this fuse over here next. Also shorted, also good. Now I didn't expect the fuses to be bad just because this power supply has the intermittent issue where it does sometimes work, but we do have a lot of sparks on screen. So what we're going to do is remove the power supply out of circuit and take a closer look. To remove the power supply, we're going to start by disconnecting a few of the connectors, and then we can unscrew it. And the power supply lifts right off. Full disclosure, this board was actually worked on in the past. When the customer sent it in, they did state that it had been worked on about 3 or 4 years ago, but now it had the issue again. So the original problem was a completely dead, no power fault, and it looks like the 2 transistors on this heatsink were replaced along with this fuse over here. Now this time around, those 2 transistors are not bad, and neither is that fuse, but we do seem to have cracked solder joints, which I will show you here in just a second. Most often when we do see intermittent faults like we are right now, cracked solder joints are the most common fault. They will occur in areas of high heat, which usually are around the heat sinks. So looking in this area, this is the transistor that was replaced in the past, and it does look like they did a really good job. I don't see a problem over here, and I did check that transistor is not defective in any way, it's fine. And this is the fuse that was replaced. We can obviously see clear signs of flux left over, and it looks like other areas were reflowed, but I don't see a problem with the work done prior. And again, that was on this heatsink right here, right next to the power plug. The next one that I want to take a look at is that center heatsink right here. It also has some transistors on it. The first one is right over here, these 3 legs. Those are that transistor. And one of the things I've already done is the transistor was covered in this silicone. So I've already removed it so we can clearly see what's going on. But because it was covered by that silicone, I know that this was not worked on in the past. Now, if we zoom in a little bit more on those 2 little joints, we can see what looks to be the start of a ring, which usually indicates a cracked solder joint. It's not fully cracked yet, but it is starting to weaken. So that's definitely something we'll want to touch up. This one's another one, same thing. It was encased, I cleaned it up. I can do probably a little bit more cleaning here, but this joint does look like it is also starting to crack a little bit right where the solder meets the actual pin. So we'll touch that up as well. And then this one actually looks pretty bad. This is the last transistor on that heatsink, and we have what looks to be a very big crack here, but it's not completely loosed yet, and I think that's probably the cause of our fault. So our final heatsink we're going to check out is over here. We have a bunch of transistors and diodes on it, and the reason we're doing the heatsinks first is because we want to check out those areas of high heat stress, which usually is going to be any component that is attached to a heatsink. And our first one is over here. That one looks okay. That looks okay. That also looks okay. We're gonna touch up all of these. This one looks like it might have been already resoldered. It doesn't look very good, so we're gonna resolder this. That one also looks okay and also like it was resoldered. We're gonna touch that up. It's looking like these 2 were also touched up, but not this one. So I'm not really sure why. It looks like just part of these were resoldered, but not all of them. So we're just gonna go ahead and resolder all of that as well. Before we proceed with the repairs on the power supply, if you have found the video helpful or useful so far, make sure to hit that like button and subscribe for more content. Now, if you don't have a soldering iron, we do offer a flat rate repair service where we will fix the circuit board for you. We'll have a link in the video description down below for that. So I'm gonna start by just adding some fresh solder here. And, my fume extractor. We're just gonna cover it up, just like that. We'll do the same with these guys. And next, we're gonna remove all of that new solder. And I'm using my desolder pump for that. All right, now I do have 2 very clean holes for the 2 lower legs. The upper one, I still have some solder in there, but that's okay. I just want to remove the majority of it. It doesn't have to be 100%. And then we're gonna add all fresh solder, and this is leaded solder. If you want to buy the same solder that we're using, I'll also have a link in the video description below to where you can purchase that. All right, we're gonna repeat the same step with this one. Just gonna start by adding some solder to all the joints. We're gonna try and remove just a little bit more off of that one. Okay, that'll do. That one's pretty good. All right, now we have a nice clean slate. We'll add that fresh solder. There we go. And this is our final one. All right, and my final step is doing a little bit of a cleanup. So I'm gonna start with the Q-tip. We're gonna remove as much of the flux as we can and absorb it. And then we're gonna finish it off with the toothbrush. And now we have 3 beautiful joints. Or I guess, sorry, 9 beautiful joints on 3 different components. All right, and finally we have this last heatsink, which has about 9 or so components. That's quite a bit, so we'll do that off screen and reconvene after that. All right, one more thing I just noticed is that some of the heatsink's grounding pads are cracked as well. So let's take a close look here. So this one actually looks okay, but this one you can see there's a very large crack going around the majority, if not 100% of the joints. So because these actually are conductive, meaning that they are going to help with the grounding, if this is disconnected, it could cause issues. So we're gonna need to make sure that that is properly soldered. And we have another one over here. And these 2 look okay, but there's definitely the beginnings of a crack here. It looks fine on this side, but it's not very good over here. So that could be an issue in the future if we don't fix it now. And it does look like these 2 have already been soldered from the prior repair. So we'll just clean that up, just the old flux. But the other side of it over here was not. And those 2 actually look okay. And they do look like they're isolated, so they don't go anywhere. So these would be okay if they were cracked. So actually these we don't need to touch up. So for these, we're gonna do the same thing. We're gonna add a lot of solder. We're gonna remove it all, or the majority of it, and we're gonna do one more. All right, and we can add fresh new solder. Okay, everything's been soldered and cleaned up. These are our nice new joints now. If you can see all of these, oh, this one needs more cleaning, so we'll have to mark that one down for more clean. All right, but you can see on these joints now, all of the solder is much more, it's flowed properly, more universally on all of the joints. This one will also need a little bit more cleaning. Okay, I'm gonna have to just do, oh my gosh, yeah, all right. These need more cleaning, but you can tell that the joints themselves look a lot better. Now, if your power supply has blown fuses or it has the completely dead no power and you're looking for a more in-depth repair, we will have that video linked at the very end, as well as in the video description below, where we do a component level repair and replacement of a lot of the components and transistors, as well as the surface mount components that you also need to replace. Now, that video has a slightly different power supply, but it's extremely similar, so you can still use it to follow along. All right, let's go ahead and live test our power supply now that everything's been cleaned up and see what we get. All right, we have had the power supply in the TV now for a couple of hours with no more problems. The TV is no longer shutting itself off. We still have perfect picture. So that does confirm we have another successful repair. If you're interested in a more in-depth video, we'll have one over here that you can check out next. As well, if you want to send in your power supply for us to fix, we'll have links in the video description below. If you found the video helpful or useful, make sure to leave us a like, subscribe for more. Thanks for watching.